Assalamualaikum and hi everyone. Welcome to Chemistry Semester 2 SK025 Chapter 1 Reaction Kinetics. In reaction kinetics, we have three subtopics: 1.1 reaction rate, 1.2 collision theory, and 1.3 factors affecting reaction rate. So now let's proceed to 1.1 reaction rate. Learning outcomes. At the end of the lesson, students should be able to define reaction rate, write differential rate equation, define rate law, order of reaction and half-life, write rate law with respect to the order of reaction, and write the integrated rate equation for zero, first and second order reactions. Overview Lecture 1. First, we will learn about reaction rate. Next is graph concentration versus time. Next is differential rate equation. Next is rate law or rate equation. Here we will learn about order of reaction and rate constant. And the last one is integrated rate equation, which is the combination of differential rate equation and rate law. Introduction of reaction rate. Reaction rate in Malay is kadar tindak balas. Let's compare the rusting of iron nails and the explosion of fireworks. The process of rusting of iron nails needs time. That means the reaction is slower. When the reaction is slower, the time needed for the reaction to complete is longer. Therefore, the rate of reaction is lower. Explosion of fireworks can happen in just a second. That means the reaction is faster. When the reaction is faster, the time needed for the reaction to complete is shorter. That means the rate of reaction is higher. So here we can conclude that when the time is shorter, the rate increases. This topic is actually very good for our economy. In any industry, normally the main focus is on the profit of the company. To gain the maximum amount of profit, the company should plan on how to increase the amount of yield or product formed by the company. To increase the amount of product, the company should plan on how to reduce the reaction time by increasing the rate of reaction and what are the optimum conditions to increase the rate of reaction. Now, let's proceed to the content of this subtopic. In this video, we will focus on reaction rate and graph concentration versus time. There are three important things that you need to learn in reaction rate. The first one is the definition of reaction rate. The second one is the formula of the reaction rate. And the third one is the unit of the reaction rate. Rate of reaction is referred to as the change of the concentration of reactant or product with time. The formula is rate equal to changes in concentration over time taken for changes. Changes in concentration, the unit is molar. Time taken for changes, the unit is second. Thus, the unit of rate is molar per second or mole per liter per second or mole per dm cube per second. The rate of reaction can be observed by watching the disappearance of a reactant or the appearance of a product over time. For a chemical reaction, A produces B. At 0 second, we have 1 mole of A but 0 mole of B. This is because at 0 second, the reaction has not started yet. So at this moment, we only have reactant in our container. The product is still not formed yet. At 20 seconds, we have 0.54 mole A and 0.46 mole B. At this moment, the reaction has already started. So the amount of reactant will decrease and amount of product will increase. At 40 seconds, we have 0.30 mole A and 0.70 mole B. At this moment, the amount of reactant continue decreasing and the amount of product continue increasing. So that is what happened during a chemical reaction. Now, let's focus on our discussion on reaction rate. As we learned before, the formula is rate is equal to changes in concentration over time taken for changes. So, the rate of reaction for reactant A is rate is equal to negative change in concentration of A over change in time. Or we can write as negative d concentration of A over dt. The minus sign here indicates the concentration of A, which is reactant, decreases. While the rate of reaction for product B is rate is equal to positive change in concentration of B over change in time. Or we can write as positive d concentration of B over dt. The positive sign here indicates the concentration of B, which is reactant, increases. To have a better understanding about progress of a simple reaction, let's take a look on the graph of concentration versus time. The graph shows the change in the concentration of A and B in the reaction against time. From the graph, we can see that the concentration of reactant A, the red curve, is decreases with time, while the concentration of product B, the blue curve, is increases with time. Example: during the reaction of carbon monoxide with nitrogen dioxide in 1 liter container, a total of 0.010 mole of nitrogen monoxide were formed after 2 seconds. Calculate the reaction rate. Reaction rate here is reaction rate of nitrogen monoxide. Nitrogen monoxide is a product. So, at T is equal to 0 second, the concentration of nitrogen monoxide is 0 molar. This is because at T is equal to 0 second, the reaction has not started yet. In 1 liter container, a total of 0.010 mole of nitrogen monoxide were formed after 2 seconds. That means, at T is equal to 2 seconds, the concentration of nitrogen monoxide is 0.010 mole over 1 liter. So we get the molarity of nitrogen monoxide is 0.010 molar. Solution. First, we need to write the formula for reaction rate of nitrogen monoxide. Rate is equal to positive change in concentration of nitrogen monoxide over change in time. We need to understand at T is equal to 0 second, this is initial condition. At T is equal to 2 second, this is final condition. So, change in concentration of nitrogen monoxide is final concentration minus initial concentration, while change in time is final time minus initial time. So, we just substitute the value into the formula. So the rate is 0.0050 and don't forget the unit is molar per second. Thank you for watching.